I am often asked a simple yet profound question: who is God? Why have we not seen him? Does such a being truly exist? These questions have followed humanity for as long as we have been capable of wonder. To understand them, we must first understand ourselves. For nearly 200,000 years, since modern humans began to walk the earth, we have struggled to explain the world around us. Imagine living in a time before science, before telescopes, before mathematics could describe the motion of the heavens. Thunder would crash across the sky without warning. Lightning would split trees in an instant. The sun would vanish during an eclipse. Crops would fail, disease would spread, and death would come without explanation. In such a world, the unknown is frightening. And the human mind does not tolerate unanswered questions easily. So we created answers. God became the explanation for thunder. God caused the rain. God controlled the seasons. When the earth trembled, it was divine anger. When the moon darkened, it was a heavenly warning. In the absence of knowledge, belief filled the vacuum. This was not foolishness, it was survival. The brain evolved to search for patterns and causes. When no natural cause was visible, a supernatural one was assumed. But as our curiosity grew, so did our courage to question. Around 300 BC, Aristarchus of Samos dared to suggest that eclipses were not acts of God but natural alignments of celestial bodies. He proposed that Earth orbits the Sun, challenging deeply rooted beliefs. That was the moment humanity began replacing divine explanation with natural law, and the search for understanding truly began. As our understanding deepened, we began to notice something remarkable. The universe behaves in a consistent and predictable way. It does not act on impulse, nor does it change its rules from one day to the next. It follows laws, precise, mathematical laws, that apply everywhere. If you throw a ball into the air, it follows a path determined by gravity and motion. Its trajectory can be calculated exactly. The same laws that govern that small ball also govern the moon orbiting the Earth and the Earth orbiting the Sun. Gravity does not weaken because someone doubts it, nor does it strengthen because someone prays. It simply operates. This consistency is profound. From the smallest particles to the largest galaxies, the universe is bound by the same principles. The forces that hold atoms together are described by quantum mechanics. The motion of planets and stars is explained by relativity. These laws are universal and unchanging. Imagine if the universe were not like this. Suppose gravity worked only sometimes. Suppose light occasionally traveled slower or faster without reason. Science would be impossible. Prediction would be impossible. Order would collapse into chaos. But that is not what we observe. The universe is orderly. It is structured. It behaves with remarkable precision. Throughout history, events once attributed to divine intervention have yielded to natural explanation. Lightning is not divine anger, it is electrical discharge. Disease is not punishment, it is biological process. Eclipses are not warnings, they are predictable alignments. When we discover a law of nature, we do not remove wonder from the universe, we deepen it. The more we understand, the more elegant reality appears. The remarkable fact is not that miracles interrupt the laws of nature, but that the laws themselves are so beautifully consistent. And so we are led to a deeper question. If everything obeys these laws, can the origin of the universe itself also be explained by them? You may now ask the most fundamental question of all. If the universe follows laws, what about its beginning? Where did everything come from? Modern cosmology points to the Big Bang as the origin of our universe. This was not an explosion in space, but the rapid expansion of space itself. If we reverse cosmic history, if we trace galaxies backward in time, we find that everything converges to an extraordinarily hot, dense state. All matter, all energy, compressed into a region smaller than an atom. Here, the insights of Albert Einstein become essential. His theory of relativity revealed that space and time are not separate entities. They are woven together into a single fabric called space-time. More importantly, time is not absolute. It can stretch, slow, and even come to a halt under extreme gravitational conditions. At the beginning of the universe, conditions were so extreme that the curvature of spacetime became infinite. This is what we call a singularity. At such a point, our current laws of physics break down. Most crucially, time itself loses meaning. If time began with the Big Bang, then asking what happened before the Big Bang is like asking what lies north of the North Pole. There is no before, because time itself had not yet emerged. This idea has profound implications. Creation, as we normally understand it, requires time. A cause precedes an effect. But if there was no time prior to the Big Bang, there was no moment in which a creator could act. In this framework, the universe did not need a temporal beginning triggered by a divine hand. Instead, time and space arose together, spontaneously, as part of the same event. The beginning of the universe was not an event within time. It was the beginning of time itself. Even if we accept that time began with the Big Bang, another question naturally follows: what mechanism allowed the universe to emerge at all? Here, we must turn to quantum physics, the strange and counterintuitive framework that governs the smallest scales of reality. At the quantum level, certainty dissolves into probability. Particles do not behave like solid, predictable objects. They fluctuate. They appear and disappear. In what we call a vacuum, what many would describe as nothing, there is still activity. Quantum fields exist, and temporary particles can arise spontaneously from these fluctuations. This is not magic, it is described precisely by mathematical laws. In such a framework, the idea that the universe could emerge spontaneously is not absurd. If quantum fluctuations can produce particles, then under the right conditions, they could produce something far larger. The early universe may have been a quantum event, an inevitable outcome of physical law. There is also the concept of total energy balance. Gravity contributes negative energy, while matter contributes positive energy. It is possible that the total energy of the universe is exactly zero. In that case, the universe does not violate conservation laws by existing. It is like digging a hole and piling the soil beside it. The positive and negative balance perfectly. Furthermore, our understanding of spacetime near extreme conditions, such as black holes, suggests that classical intuition fails. At a singularity, the known laws break down, and quantum gravity must take over. In such extreme environments, spontaneous creation becomes theoretically possible. The crucial point is this: if the laws of physics permit spontaneous creation, then the universe does not require external intervention. The laws themselves are sufficient. The mystery, then, is not how God created the universe, but how the laws of quantum physics made it inevitable. Now we arrive at the most personal part of this discussion. Even if science provides a framework in which the universe can arise without a creator, the question of God does not disappear so easily. It shifts, from physics to philosophy, from cosmology to the human mind. Religion has played a powerful role in human history. It offers comfort in times of despair. When people feel alone, they speak to God. When they suffer loss, they seek reassurance that their pain has meaning. The belief that someone is watching, listening, and caring can provide immense psychological strength. Places of worship bring peace to many. The idea of divine justice can discourage wrongdoing. If someone believes that their actions are observed by a higher power, they may act more responsibly. In this sense, belief in God can serve a social and moral function. But science asks a different kind of question. It does not ask what comforts us. It asks what is necessary to explain reality. And when we examine the workings of the universe, from the motion of galaxies to the behavior of subatomic particles, we find no requirement for divine intervention. Some propose alternative interpretations. Perhaps God is an advanced being from a higher dimension, or the architect of a grand cosmic simulation. These ideas are imaginative, but they remain speculative. Without evidence, they belong to philosophy rather than physics. If we claim that God created the universe, we must then ask: who created God? If complexity requires a designer, then the designer must be even more complex. This leads to an infinite regress. Science seeks simpler explanations, models that require the fewest assumptions. In that pursuit, the universe governed by consistent laws is sufficient. Whether one believes in God is ultimately a personal choice. But from the perspective of physics, the universe stands complete without invoking the supernatural.